time I say so, I think of SOHCAHTOA. It's horrible. May 26. We're so close, folks. We are so close, but you got to keep pushing, right? Just let's get to the end of the year. Okay. So let's get to the bottom triangle. And all I want us to do is label this triangle with our lowercase letters. I'm not going to draw the height. And so for acute angles, what you did is you came up with the sine law. And the sine law looks as such. There's two versions. A over sine A equals B over sine B equals C over sine C. But some of you folks ended up with having the sines on top. Well, that's another version. Sine A over A equals sine B over B equals sine C over C. And I don't actually care which one you use because we're going to solve using the T method. It doesn't matter at all. So what this formula says is if you write a ratio of the side length compared to the sine of that angle, they are all going to be equal ratios. Guys, okay, they're all going to be equal ratios. So let's see how we're going to employ or use this sine law. Next page, example 1. Go ahead and read it. Let's do some active reading. So highlight or underline what you have, circle what you need. Did you circle the 3 words that tell you what you need to do? Sophie, is everything okay? You got a question? Okay. What are the 3 words that tell me what I need to do? Tell the person sitting next to you. That's it. Solve the triangle. This is what you need to answer. And I circle it so that I go back to that beginning of the question and I'm like, did I do what I was supposed to do? Now, in addition, I'm being told how to round. And on the quiz, folks, a lot of students lost marks for either rounding incorrectly, like rounding up when you were supposed to stay down, or for using too few or too many decimal points, right? So I'm going to be really picky about rounding. So round each side to the nearest meter. All right. What's a good thing to do at the start? What do you think Miss Sly would tell you to do? Yeah, absolutely. Folks, do you think it matters if R, S, or T are at the top? No. So we can all draw our triangle, however, and also the triangle doesn't have to look to scale. It's just like, all right, just some kind of triangle. I'm going to call this R. I'm going to call this S. I'm going to call that T. Doesn't matter. Oh, look, S is 83 degrees. I didn't make it look 83, but it doesn't matter. It doesn't have to be to scale. T is 26. Always adding that little degree symbol. And then we get that lowercase r is 53 meters. So that's 53 meters. And I'm going to use a different color to show what I need to find. I need to find angle R. low sides S and side T. Okay, so I'm given, how many pieces of information am I given? Show me with your fingers. Tres, muy bien, good. And how many pieces do I need to find? 3. Every triangle has 6 pieces of information. 6 sides, 6 angles. Okay, sorry, whoa, 3 sides, 3 angles. Okay. Which one is easiest to find? Yeah, it is, right? So let's start with finding angle R. And I number my solutions because they're going to go all over the place. So we're going to start off by finding R. And I might go like, I might write this to say, hey, I don't know what R is. I'm going to find it. What is that theorem called? Let's write it down so that we know the word. Opposite? No. Oh, there is no, I was thinking OAT. It's not. Sum of angles. Use sum of angles theorem. Theorem is kind of like another word for rule. So we know that the internal angles of a triangle, the sum is 180 degrees. And so watch, this is how I want you to write it in grade 10. Angle R equals, right? You start with what you're solving for. Okay, 180 subtract 83 subtract 26. Every single student has a calculator. If you don't, come on up and grab one. Try to do this in your head. 97, 91, 71. Good. Is it exact or approximate? Good. 71 degrees. I didn't have to round, so it's an exact answer. Part 2. Yeah. So now I need to solve for sides T and S. Doesn't matter which one. Let's go alphabetical. Let's find side S. What's the tool we're going to use? Take a wild guess. Anyone? Yeah. Why else would we be practicing this? We're going to use Sine Law. Now, in the Sine Law, there are 3 fractions. We only need 2. Do you think we're going to use, so what's one of them that we're definitely going to use? R, S, or T? Okay, why do you say R? T? Why do you say T? So what I want you folks to do is decide which 2 angle side pairs are we going to use. Talk to your people, don't talk to me. So we're going to have something like this, S over sine S. We can only use 2 of them. Which one? Which one gets cut? All right, come back here, folks. Which one am I cutting? T. Okay, how come? So which one is the one that I have both values for? R. I have both of R. Which one is the one that I need to find? I need to find S. So it's one of those like Sokoto. It's like circle what you have, circle what you need. Okay. As such, I'm using R and S. I only use 2 of the ratios. Let's enter the information. And I happen to put sine in the denominator. It doesn't matter as long as it's the same. It's both in the denominator. Okay. What do I know? So I know that R is 53. And angle R, I found it, 71. I know that sine S is 83 degrees. And I don't know side S. I'll make it pink so you can see. So in that formula now, there's only one unknown. And so I can find S by using the T rule. This times this divided by that. So let's write it all out. 53 times sine 83 degrees divided by sine 71 degrees. And then everyone's punching it in. Round each length to the nearest meter. And so I get that S is approximately 56 meters. Yes. Oh, did you want to tell me?
Yeah, I'm going to say since it was, the answer was 50, 56, like 6,
It was 50, yeah. Yeah. So it was 55.6. We have to round up. And did everyone add the approximate equal sign? Okay. Move on to the last piece. Side T. Now in this case, we've got all the pieces except for T. So we can use any ratios. However, I'm going to tell you, I generally try not to use the one that's approximated. So I'm going to try, if I can, I'm going to try not to use side S because it's already been rounded. So it's not an exact answer. So in that case, I'll use T and R. And just to get some experience, we're going to put the sign at the top. So we'll write sine T over T equals sine R over R. I'm literally just putting it in the sign in the numerator just to show that it doesn't actually matter. Now, are you going to lose communication marks? Check what you just wrote down. Are all the angles uppercase and are all the sides lowercase? And if not, change them. Okay, rewrite the formula now with the values that we have. I'm making sure I'm writing degrees each time. But I don't have to write meters. Yeah.
You're using R because you didn't have to round and the answers were already given to you.
That's right. And then I use the T rule. This times this divided by that. So I'll get that T equals I already know it's going to be approximate, so I right away wrote approximately. Everyone is punching it in. Once again, I had to round up. Yeah. right? It's 25 because 24.57 is going to be 25. Questions? Okay, folks, I want to introduce a critical thinking tool. This is so helpful. And in grade 11, it's going to be so helpful. So listen up. When I say critical thinking tool, I say this is a tool you use after you finish the question to ask, does it make sense? Right? So critical thinking is asking, does it make sense? Based on what I know about triangles. Okay. So I want you to take your arms, put them together. Now make an angle of approximately 10 degrees. I don't know, just make it up. How far are your hands? How far apart are your hands? I don't know, 10 centimeters, 20 centimeters. Okay. Now make an angle of 75 degrees. How far apart are your hands? More further or closer? Okay. So listen to this. Here's the question. When you have three angles, okay, in this triangle, we have 83, 71, 26. Which side must be the shortest side? R, S, or T? How come? Because it's across from the smallest angle. If you have 26, well, my fists aren't that far apart. But if I have 71, oh, look, my fists are further apart. 83, even further. So the tool of doesn't make sense is the shortest side, does the shortest side correspond to the smallest angle? Yes? Does the biggest side correspond to the biggest angle in this case? Okay, and then middle and middle? Perfect. So does it make sense? Yes, it does. That's the tool I use. And I'm going to be reminding you to use it every time we do a question. All right, let's try another one. Yeah. So we use the sine law to find side lengths. In this question, we're going to use the sine law to find angles. Okay, so once again, we're doing some active reading. What are the three words that tell me what I'm supposed to do? Say it out loud, folks. Beautiful. All of them. Solving means find everything you can about that triangle. Okay, different kind of rounding. So we got to be careful. Once I finish my active reading, what's the next thing we'll do? Draw a picture. I mean, it's a diagram, right? But it doesn't have to be to scale. So let's just draw the picture. Again, doesn't matter where D, E, F goes. I'll just place them randomly. And then I might also add my lowercase letters, just so I'm for sure not getting mixed up. And I'll add the info I know. So now I want you to come up with a game plan. There is actually only one correct first step. The second and third step can be changed. There is only one piece you can solve for first. Talk with the people around you. What is it that I can solve for? All right, I'm hearing the buzz. Why am I solving for angle D? What is it, Maya? Okay. Which corresponding side angle do I have absolutely no information for? Right. So I can't start with that. Okay. So step one, we're going to find D. Great. Step one, find uppercase D because that's my angle. What is the tool I'm going to use? Yeah, I heard it. Sine law. Does it matter if sine is in the numerator or denominator? No. I feel like putting it in the numerator. Great. And we said that we're going to use F as the second pair. So go ahead and substitute the values, solve, and then look at what I did to see if it matches up for you. Yeah. Yep. You got it. So you're going to get a value for sine D, and then you must inverse it to get the actual angle. Good. Good question. Yeah, because this is still the same sine that we know. Okay, T rule. And so here's the really important piece. When you do the T rule, I'm not finding D right away. I'm finding sine D. That's where a mistake might happen. And if you wanted to, you could write D equals, but have the sine inverse already on the right side. I won't do that. I'll just, okay. Did you get 0.8740, blah, blah, blah? No, don't round it because that's not the final answer, right? 0.87 is not the angle, it's the ratio. So yeah. So I'm writing it down, but I'm just writing it down so that you can see it, but don't. After this time, we're going to stop writing it down. I'm keeping the number in my calculator. Yeah. Yeah, and I'll show you in the next one how I would communicate it better. Right? But I do want you to show that you're using the sine inverse. And what am I rounding to? Each angle to the nearest degree. Yeah. Did anyone else get something other than 61? So if you got anything other than 61, it tells me that you rounded sometime in the question. Do not round until you get your final answer. There's no creativity to this, so it must be the same answer. Yeah. Absolutely. And I'm going to do that in the next question. Actually, I can't do it in the next question, but yes. So, folks, let me show you what the alternative would be. So, what I was asked is, can I do this instead, Miss Sly? Is that what you mean? Yeah. I prefer this. I like this more because then you don't have to write some decimals down. Okay? Either way, fine, as long, but like just don't round anything until the end. Okay? Either one works. All right. Okay, next. Actually, I wasn't, I made a mistake. I said that step 2 and 3 can be interchangeable, but that's not true. So talk with your people. What is the next thing I must find? Step 2 is what? There's only one option again. You got it. Solve for angle E. And what's that theorem called? What's the tool I use? Sum of angles. Good, that's my tool. Okay, so E equals 180. Subtract 61 degrees, subtract 35. Now, some people are going to be super keen and be like, hey, Miss Sly, I'm using a rounded value, so I'm already going to use an approximate equal sign just to show you that I know that these values are not exact. And I'm going to try to do it in my head. Did others get 84? Yeah. Okay, thank you. Okay, last step. Do you see how my solution is sort of all over the place? But as long as it's numbered, I consider it organized, right? Because you can follow along with my numbers. So last thing we find is side E. And what's the tool I use? Good old sine law. Good. You don't have to write down tool, but it's again really good critical thinking to always consider what tool I'm going to use. Now I feel like putting the lowercase letters in the numerator. Doesn't matter. And then, should I use F or E? There is a better answer, folks. Not E. F or D. What's the better answer? Good, because it hasn't been rounded. Great thinking.
And should we put the approximate equal sign because E is rounded?
You could. Yeah, you totally could. You could be like, yeah, I already rounded angle E. So, yeah, it's going to be an approximate solution here. Great. Good thinking. Now we sub in the values we know. Okay. F is 42. Oops. E is 80. I'll use the T method. This times this divided by that. How many decimal places?
Yeah.
Is that true? Oh, yeah, it is true. Okay. Thank you. 42 times sine 84 divided by sine 35. 73 meters? Is that what we get? Great. If not, okay, I got one head agreeing with me. Are there other people that agree with me too? Anyone else? 3? Whew, okay, that's critical mass. Good. Now, if you want to be really keen and provide a beautifully looking solution, we can make a therefore statement where we list off what we found. Angle D, 61 degrees. Angle E, 84 degrees. And side E, 73 meters. Yeah.
Wait, this is kind of a question, but how do we get answers with sine if sine is in the numbers? How can we multiply things from sine to the ratio?
How can we multiply? Like, how do I get a number from sine 84 degrees?
Yeah.
Okay, that's a cool question. So, what we learned, and it's kind of hard to wrap your head around, I will give you that. So, 84 degrees. So, what I've learned about the sine ratio or any of these ratios is that the size of the triangle doesn't matter. Every triangle that has 90 and 84, they're all going to be similar triangles. And that means that the ratio of the opposite side to the hypotenuse is always going to give you the same number. Whether I get 100, whether like opposite is 100 and hypotenuse is 200, whether opposite is 50 and hypotenuse is 100, whether opposite is 2 and hypotenuse is 4. What this sine of 84 says is that I recognize that anytime your angle is 84, your hypotenuse is going to be this much bigger than your opposite. Okay? That's kind of the definition. Let's talk more. Okay? Maybe I can explain it differently another day. Okay, because I want to get to this word problem. Oh, because we got some angles of elevation and depression. Woohoo! Okay, folks. In this diagram, is 48 degrees and 59 degrees, is it an angle of elevation or is it an angle of depression? Okay, talk to your people. Okay. Come back here. Put your arms out like this. Everyone. Okay, one arm remains always as the horizontal. You must have a horizontal because we go from the horizontal. So now use the other arm. Make an angle of elevation. Elevate your arm. It's where my head is, right? That's the angle. The angle is not here. It's between the horizontal and my arm. Put your arms back down. Choose which one is the horizontal. Make an angle of depression. What is the angle we're talking about? Is it between my body and my arm or my two arms? Right. This is the angle of depression. Okay. So what do we have in this picture? Angle of depression. Good. Now, does it matter? No. Let's read the question. A ship is in trouble. Oh no. It's spotted by a man on a cliff. Yay, man, you're going to help us. Let's call you M for man. Okay. Determine the, ship, why don't we call the ship S? So creative. Determine the direct distance between the man and the ship, given the following diagram. So the words don't say it, but there's a helicopter that is level with the man, right? This is horizontal, and it measures that it is 265 meters away from the ship, right? And it measures that its vision, like its sight line, is at a 59-degree angle of depression. Now, whether you understand this picture or not, it's just a triangle, right? Let's call the helicopter H, and let's redraw the triangle. Like you could say, I don't get this situation. And it actually doesn't matter. In some word problems, it will matter. But in this one, because we have the diagram, it's like, okay, I know this is 265 or 265 meters. And I know that I'm looking for this. What's the letter I use for the question mark? I'm looking for lowercase h. Question you're going to ask yourself. Can I use SOHCAHTOA? No, you Miss Sly, don't do it. Don't use SOHCAHTOA. Why can't I use SOHCAHTOA? There are no right angles in this triangle. Whew. Sorry. All right. So what do I use? What's my tool? The sine law. If I don't have a right angle, I use the sine law. I'm going to use my h. And which other pair am I going to use? M. Notice I'm not even solving S, right? It doesn't say solve the triangle. It literally says find h. Just find that distance. Okay, so I know we've got 30 seconds. Let's find it. Okay, we're going to do T rule. We'll figure it out. And then we'll say, does it make sense? I'll do sine 59 times 265 divided by sine 48. And I get a distance of approximately 306 meters. Yep. So if you look at the Google Classroom, I've updated the table of contents. In case you're confused, I've actually changed the dates. So today, you are doing the sine law homework, the 6.9. Does that make sense? Folks, do you know which you're doing sine law homework, 6.9. All right.